All right, so in our quadrilateral family tree, we're going to talk about parallelograms, which was on the right side. And a parallelogram has two pairs of opposite sides that are parallel to each other. Now, in parallelograms, there's a lot of theorems, a lot of properties, a lot of definitions that take place. And these are very important to know because they're going to allow us to solve mathematical problems in our tests, our quizzes, and our practice problems. So the first theorem says opposite sides of a parallelogram are congruent. So if one side is 12, the opposite side will be 12. The next property we're going to see involving angles is that these two angles in this parallelogram are called consecutive angles. These two angles here are called consecutive angles, and consecutive angles are going to be supplementary. So this angle plus this angle are going to add up to 180 degrees. So if you take 180 minus what's given, you'll get the other angle, which would make it consecutive. Okay. All right, the next property here involves opposite angles. So we have opposite sides are congruent, consecutive angles are supplementary, and now we have opposite angles are congruent. So in this parallelogram, these two angles are going to equal to each other. So in this case, they give us two expressions, which we can set equal to each other and solve. So in this case, we would set them equal to each other, and we would get y equals 11. And if we read the directions, which is really important, we have to plug in and solve for these. But because opposite angles are congruent and consecutive angles are supplementary, we only have to find one angle to figure out the rest. So if I plug in y equals 11 to either expression, in this case I use this, 6 times 11 plus 4 is 70, that means angle G has to be 70. And then G and H are supplementary, so 180 minus 70 would be 110. And H and F are congruent because opposite angles are congruent. All right, we're going to talk about diagonal properties as well. So we have sides, angles, and diagonals, SAD. Okay. So the diagonals are going to bisect each other. So this section and this section are going to be congruent. This section and this section are going to be congruent. So that's what that's saying. Now in this example, this is a little bit more difficult than we're going to do, but A would equal to B plus 2, and B plus 10 is equal to 2A minus 8. All right, so we're going to skip this example pretty fast. All right, this theorem we don't really focus a ton on, but what it says is if you have 3 or more parallel lines with transversals and the distance between the parallel lines is the same, then the distance on these are going to be the same as well. Okay, so that's not something we spend a lot of time on. All right, here the diagonals of a quadrilateral bisect each other, then it's a parallelogram. So this is really saying the opposite direction of what we just said a second ago. If we have a parallelogram with diagonals, they bisect each other. But what if we didn't know what parallelogram it was? If we know the diagonals bisect each other, then we know it's a parallelogram. So that's what these two are saying here, is if you don't know what shape it is, but you know the properties, you can then determine the shape. Where the first few theorems talked about if you knew the shape and the part, then you had a property involved. Okay. All right, so down here we see an example, and we know these two angles are not congruent because they're not the same size. They're in fact they're consecutive angles, which are supplementary. So we're going to add up both parts, and they'll equal to 180. All right, and we get A equals to 70. And then we know opposite sides of a parallelogram are congruent, so we'll set these two equal to each other and get C equals to 2. And if you read the directions, we're all set with what we need to find. Okay. All right, now here's the diagonal property of a parallelogram. So we go back to what we remembered. Diagonals are going to bisect each other. So this will equal to this part. This diagonal part will equal to that diagonal part. And so we go ahead and solve these two, and we would get these two answers. All right, the next theorem says if both pairs of opposite angles are congruent, then we must have a parallelogram. So if opposite angles are congruent, then both pairs are congruent. We have a parallelogram. All right, so what this is looking at here is based on what's given, can you use this given information to prove that this is true, or to prove it true with the other theorems? Okay. And so you need to make sure you understand those definitions, theorems about sides, angles, and diagonals for parallelograms, and also any other shapes that we study from here on out.